Hi, my name is Amr Khalil.
My name is Mikhail Kling.
Hi, my name is Suleiman Thurman.
Hi, my name is Sebastian Mihulad.
Hi, my name is Umar Siddiqui. Part of the process for improving antibacterial wipes involves generating some samples of how the solution streaks across a surface, or as we call a substrate. It's important to generate both a lot of substrate samples while maintaining consistency. You don't want the user's pressure to be a variable when you're testing wipe properties, but you also want a lot of samples to test. This is the perfect job for automation. So the goal of this project was to develop an automated environment that can wipe antibacterial napkins on a substrate while maintaining a consistent pressure. Our design process starts with asking, what is it that we really need? At the most general level, we need some environment to both hold samples and move a wipe around. What kind of motion do we need to make that happen? Radial motion seems okay, but is a bit complex. We're fine with a lot of straight lines, but it just needs to be precise. While Cartesian motion is simple, easy to implement, and most importantly, accurate. So that's what we decided to go with. What kind of machines can give us this Cartesian motion? Well, our first option was a Cartesian robot. These are commonly used in high-precision automated manufacturing spaces, more specifically pick and place. We found a Cartesian robot that we liked, but at around $10,000, is a bit out of our price range. So the next challenge was to either find or design something cheaper. Now, as it turns, 3D printers offer the exact same type of motion with the added benefit of extremely good precision in the z-axis. This allows us to really fine-tune our application force. After some research, the group decided on the $200 Creality Ender budget 3D printer, certainly a far cry from $10,000. Now, we need a gripper to hold the wipe in a realistic way. After a lot of iterating and designing and redesigning, eventually we settled on this. The larger, flatter piece acts as a thumb with two fingers that close together to pinch the wipe in place.
The gripper has went through 6 different design iterations, hence the Mark 6 listed on the back plate of the gripper. The tip of the newest gripper, as shown, is coated multiple times with a silicone finish to allow a better grip on the wipe.
Finally, we need a tray to hold all of our substrates. After some iteration, we landed on this design. The substrates are arranged on a grid on the tray, with wipes held vertically in these slots. Underneath the tray are magnets that help it clip to a holder that's been mounted to the bottom of the 3D printer. The holder is fixed, while the tray can be easily unloaded and loaded.
A quick overview of the process. This entire process is run by a code written in Python that interfaces with a Raspberry Pi. The Raspberry Pi then talks with the motor that is controlling the gripper and also talks to the processor of the 3D printer that is controlling the 3-stepper motors in the XYZ planes.
Now, let's see it all come together. The robot starts by traveling to the first napkin position, picks up the first napkin, and goes to the first row. The robot then repeats this cycle down the row. EPA guidelines require 4 wipes per substrate sample, which the robot performs. After completing a row, the robot discards the current napkin. After discarding, the robot picks up the next napkin and repeats the cycle until all the substrates have been wiped. The holder is fixed, while the tray can be easily unloaded and loaded.
In summary, we have created something in which allows for a highly consistent pickup and wipe.